Okay, we're going to go ahead and get started here. Hello, everyone. I'm Jeff McChesney. I'll stop sharing here for one quick second, give you a full screen of me. I'm Jeff McChesney. I'm CEO and founder of Target Arm, and we're going to be going ahead and starting with a webinar with our guest, Ted Maciuba. So let me just share my screen real quick and bring it back. Thank you very much for your time. Very much appreciate it. What we're going to talk about today with Ted is the future of military robotics. Ted's going to be our guest speaker, and we're looking forward to hearing what he's got to say, especially with his expertise that he's got. Just a short background of Ted. Ted is a principal consultant for Maciuba Consulting today, dealing in the robotics and autonomy space. He previously was in the U.S. Army. He was a West Point graduate and got his master's degree also from the University of Texas. At Austin. He's a professional engineer, and he's had various opportunities throughout the Army, including being a helicopter pilot in the aviation arena as well. But he's the chief of combat development in the Army at the U.S. Armor Center, the deputy director for mounted requirements at the U.S. Army Maneuver Center, and the deputy director for robotics requirements, where I first met Ted back when he was down at Fort Benning, now Fort Moore. Ted's got a wealth of background in robotics and the way that the Army views this across the globe, including our allies, and has been involved in numerous reports and writings and strategy for the United States Army. So I'd like to welcome Ted. And Ted, I'll turn it over to you just in a moment. So first thing I want to say is that Target Arm has an integrated product line that we're dealing in the same space that Ted's dealing with today. And that our signature device, TOOLAR, enables you to launch, recover both rotary and fixed-wing drones from any moving vehicle. We can do that fully autonomously. These are some of the examples, both rotary and fixed-wing, that we have. But our integrated products that we bring to the market are both our TOOLAR device, our sensor fusion engine, our wraparound flight controller, and our Maestro mission control. And all four of those provide the ability to do vehicle movements and anything that's moving both in the commercial and the military arena, as we show on the right here. And that's why it's so important to understand what Ted's talking about, because on the military side, where the robotics world is going, especially with the war that's going on in Ukraine, we're looking very forward to hearing what Ted has to say. So Ted, I'll turn it over to you, and I will switch over for your slides here in just a second. There we go. So Ted, over to you.
So thanks, Jeff, and thanks for that introduction. If I can give a little bit more background about me. So I have that engineering degree from the oldest engineering school in the United States. In fact, Jeff has a degree from one of our satellite campuses that came about after the schism of 1947. But I also, while I was there, was interested in operations research, the idea that you can come up with better answers. And one of the reasons why when you buy airline tickets these days, you never know what the price is going to be until you get online. That yield management is one of the major outputs of operations research, but it also does many other things as you look at the data that's out there and try to make sense of it going forward. And that's really what I've been trying to do really for the last 30 years within the combat vehicle realm, and for the last 6 years within robotics. So if we can go on to the next slide, please, Jeff. I think many of you may be aware that Robert Work was the Deputy Secretary of Defense back about a decade ago. And I'm not going to go through the individual offsets because Jeff only gave me 15 minutes. But what I did probably 6 or 7 years ago was I took what Secretary Work had done with the overarching Defense Department view of offsets, and I pulled it down into something that infantry and armor general officers could understand. And everything was in terms of soldiers, bullets, and kills. And so I could spend some time talking about how we got there. But Robert Work's vision was that we were in the third offset where we had to start producing systems that were which would give us an order of magnitude increase in effectiveness, so that we could outdo our adversaries going forward. And that was the third offset. If we can go back, Jeff. So that was the third offset, and that was robotics, autonomy, and artificial intelligence. So I've been in the Army. I've been a bureaucrat, faceless bureaucrat. But really, when you look at this as a vision, we within the Army, and I will talk in that corporate we, should have grabbed this and sent it forward. So there was a guy named Hillner at the Center for Army Lessons Learned that back in 2019 wrote a monograph, and you can find it on the internet right now. And he basically said, here's what Secretary Work has told us to do. And actually, back in 2019, Secretary Work was gone 3 years, but still, as a conceptual viewpoint, this is what the Department of Defense asked us to do. And then he looked at the actual modernization priorities within the Army, and there was a disconnect. Basically, no money was not enough money was going against these ideas of robotics, autonomy, and artificial intelligence, and too much money was going into industrial age capabilities that the senior leaders were very comfortable with. So back in 2017, the chief of staff of the Army, who basically went on to be the chairman of the Joint Chiefs, Mark Milley, put out guidance to the Army that he wanted to get a dismounted infantryman that was 10 times as lethal as they are right now. So we did a couple of things within the Army. We actually developed a soldier lethality cross-functional team, and they just are going down the path of building a new or fielding a new weapon to each of our dismounted soldiers in the close combat force, somewhere on the order of 100,000 soldiers. Unfortunately, that 10x increase in lethality will not come from a 20 or 30% increase in the lethality of their individual weapon. So at the same time, we went down the path within robotics requirements of asking industry to help us meet that 10x goal. And the second reference, Garth McDermott was actually a Naval Postgraduate School student. He took data that came out of a 10x robotic and AI enabled dismounted infantry platoon simulation experiment that we had done at Fort Benning, now Fort Moore, and he wrote an unclassified report, and he did it in a very elegant way. For those of you who are interested, and if you want to go to the Military Operations Research Society website, you can actually download the report. And in there, we started with the idea that there were technologies that if we would just find them, if we would just pull them together into a system of systems, we could actually have that 10x increase in lethality. So the simulation experiment had really three major weapon systems on there. One was a 30-millimeter cannon on a small multi-purpose equipment transport, the SMED, which is actually a program that has now been fielded, and we are going into the second increment of. We had small unmanned aircraft system drones with weapons on them, and we had loitering munitions on estimates. And we were able to demonstrate in that simulation experiment that we could get to greater than 10x increases in effectiveness, increases in lethality, increases in situational awareness with these kinds of technologies. And this was back in 2019. So what we did not highlight at that time, and what I have since come to realize was the key enabling technology, was the ability to autonomously launch and recover armed small unmanned aircraft systems. And really, if you could launch and recover loitering munitions, now you have that ability to push those out in front of our manned formations. So those are two very interesting references, and for those of you who are interested in the future, both of those are things that I'd recommend that you look at. So next slide, please. So in terms of the actual critical robotic critical enabling technologies, really for the last probably 8 or 10 years, we've recognized the fact that you need to have assured communications, you need to have autonomy, you need to have artificial intelligence, and really, probably the hardest thing there is the energy. But the energy is there so that you can have persistence on the battlefield. There are other ways of getting persistence. One of those is by putting multiple systems out there. So as an example, with a small UAS, you may not be able to get away with a small UAS that can be out there for extended periods of time. But if you have multiples of that, 2, 3, 4, 5, you can have one out there with that kind of persistence that you need on the battle. But really, I think the autonomy and the artificial intelligence is in some ways low-hanging fruit, and I think that's the place where Jeff and the folks at Target Arma are doing some great work. Next slide, please.
Yeah, I will, Ted, just 1 second here. So if anybody's got any questions, you can go ahead and put it in the Q&A, and I'll bring those forward. With the small group that we have today, we'll probably turn around and actually go live, so you can actually ask questions at the end as well. The next slide itself is going to probably generate a lot of questions. Thanks, Ted.
So one of the things that I did on my last day in federal service, which was the 30th of December, 2022, was I hit send on the Army's robotics and autonomous system strategy. And by the way, it is still in draft. They're still working on it. But one of the key things that I developed was this chart. And the third to the last thing I did on that last day was wipe the whiteboard where this was sitting. And it had been something that we've been working on really since probably 2018. And so I'm not going to talk about specific systems, but really on the left are all of the systems that right now are being fielded to the force. Every single one of those systems is fielded with its own controller. And so RAC-2, Robotics and Autonomous Command and Control, is the first system that will have commonality of software across all of the systems that we have. So RAC-2 will be able to control the systems that are out there right now, and then it will be controlling all of the systems that that the Army is looking to field in the near term. So I think that is the first big step forward to move from a whole bunch of systems with a whole bunch of controllers And moving forward, we collapse down to a control software, and that control software can sit on a soldier held device. It can sit on a device inside of a combat vehicle. It can sit on a device inside of a helicopter. It can sit on the device inside of a command post. So it is the same technology that basically permeates all of those places where you have soldiers who are controlling robots. It also allows you to reach up and be able to control the payloads on systems that you are not controlling yourself. So again, that allows you to reach up and grab a missile that is on a different system that is not inside of your brigade combat team, 4,500 armor and infantry soldiers. That might be inside of an aviation brigade. So the next step beyond that, and a step that is going on, is to develop technologies for those things that I talked about in terms of the critical enabling technologies, that assured communications, that autonomy, and we separate out the narrow AI from the AI cloud. And the narrow AI is what sits on the robotic system itself. It is what gives it the ability to learn from the environment that's out there. And then the AI cloud then is taking all of the information that's coming from the robots, that's coming from the sensors on soldiers, that might actually be coming from echelons above the platoon, the company, the battalion, the brigade, and pull down those that information and really build a battlefield visualization that is then presented to the soldier in some kind of a visualization system. And I've got the integrated visual augmentation system, which is a program that's ongoing right now, that I think is an exciting way moving forward. It's still got some problems, but there has to be a way for the information to be provided to the soldier themselves. And then the step beyond that now is to take all of that and put it together into artificial intelligence for small unit maneuvers. So I talked about how in 10X you had to have these the technology to launch and recover small UAS. Now you start to get to the point where you are controlling the robots now by that AI for small unit maneuver. And then you have the AI sum is the interface between the soldier and the robots that are out there. And I think the target arm technology is on the other side of AI sum, because that is what is allowing the small UAS to go, and the loitering munitions really, to go out there and extend the reach of that small unit. So I think I've reached my 15 minutes. I might even be a little bit over. So I will stand by for any questions on this or any of the other slides that I have. And I'm also willing to entertain any other specific questions that that you have as to how the Army works or does not work going forward. Over.
Okay, great, great, Ted. Thank you very much. You know, one of the things that that I want everyone to understand is that you should be able to come out and if you can't, let me know, but go ahead and ask a question if you have it by coming live. Ryan, could you just, I think you're on there. Ryan, could you just come live, just make sure that we've got that system set up? Maybe, maybe not. Does not sound like it. All right, let me just see if I can set that for everybody. If you have a question, go ahead and ask it in the Q&A. Ted, I'm going to work on this, but I'm going to ask you one question if you could address this for everybody. And that is that, you know, the traditional Army with its maneuver warfare as a tenet of, you know, operations created the concepts of, you know, forward line of troops. And as we've progressed through time and we've started getting robots and autonomy, there's this new concept that is talking about using the forward line of robots. Could you articulate a little bit about how that evolved and where that's going and what that means to the Army of the future?
Absolutely. Probably 4 or 5 years ago, the Army formed the Next Generation Combat Vehicle cross-functional team. We at Robotics Requirements, actually, we had a different name back then, but it evolved into Robotic Requirements, came up with the idea of the robotic combat vehicle. And it was such a good idea that the Next Generation Combat Vehicle folks said, hey, this is something that we want. So they pulled it up to their level. And they have a general who is the director of that cross-functional team. And his staff came up with the idea that right now we think of the forward line of troops, and that's where our soldiers are. In front of that forward line of troops should be a forward line of robots, and then in front of those forward line of robots should be a forward line of sensors. And so that kind of a construct is something that has resonated with people. There's been a lot of talk over the last few years that the first thing that should go through a door or go into harm's way should not be a soldier, but it should be a robot. And so I think we are putting those robots out there to be able to extend the reach of our manned formations. I will tell you at some point the difference between having a robot as a sensor and a robot as a robot kind of blend together. But I think if you think about sensors in terms of things that can't necessarily move, it kind of makes sense there. So sensors that are out there that are looking for movement, that are looking for seismic activity, that are looking for other types of enemy movement that are relatively inexpensive, disposable. They are put out there to find out what's going on, and then the robots are the things that are between the soldiers and those sensors to first confirm or deny that things are going on that the sensors say are going on, and then be able to do something about it. Over.
Okay, great. Thanks, Ted. I've got a couple of questions that have come in. I'll go ahead and start asking them. Thank you very much for typing them in. The first one is Ted, how do you see narrow AI expanding into robotics operation in the defense industry?
So I think I would say that that's already going on, and I would also say that narrow AI is something that is dual use. It's something that you're already seeing in autonomous vehicles. So now it's a question of how do you leverage what's the work that's going on with autonomous vehicles on the road into autonomous vehicles in cross-country unstructured terrain, with that terrain constantly changing when bridges are destroyed or you have impact craters or things like that. You have to get that AI forward onto the platform so that that platform can make appropriate decisions in the same way that a 19-year-old soldier makes those same decisions. One of the interesting things that Jeff and I have been discussing is the difference between machine speed and soldier speed. And one thing that and I think Jeff came up with this idea of the human thinks at 10 hertz. Machine speeds, and let's say it's you've got a gigahertz processor. That gigahertz processor is multiple orders of magnitude faster, but the soldier at 10 hertz can make better decisions based on the fact that they are inside of that environment, and also they have the advantage of better learning within the environment of cross-country mobility. So how do you take what the machine does at a gigahertz and what the soldier does at 10 hertz, and take how do you have the soldier do what they do best and the machine does what they do best? And that's the idea of human machine interface. And I think the AI that's there, that the narrow AI is also needs to be there for when the soldier is not available, to be able to come up with solutions for edge spaces. And what we should be working towards is reducing the number of edge situations, so that there are fewer and fewer times when where the robot has to ask for help from the soldier. So again, I think this is very very interesting in terms of leveraging what industry is already doing in the commercial sector, and then moving that over into the kinds of things that the military sector needs to be able to make its robots do the things that they need to do to make that small unit more effective. Over.
Okay, great, Ted. Thanks very much. Got another question for you, and we could do this probably together if you'd like, but we'll hear your views primarily. And that is, can you please go into a little more detail on how you think the 2LR system will work on the battlefield and how it would be used in the forward line of robots?
Absolutely. In fact, let's go back to the 10X robotic and AI platoon simulation experiment. So we started with this idea that we wanted this organization to be 10 times more effective. We asked industry to propose technologies that that would allow us to do that, and we took those technologies and we played them in a classified scenario. We really didn't have sensors per se. I take that back. We did have sensors. They were not necessarily played within that simulation experiment. We only selected those after the fact when we were doing our actual soldier experimentation with it. So in the simulation experiment, we had UAS on an SMET, and we wished away how we were going to launch and recover those systems. And so it was almost like a technology that we were aware needed to be developed, but for a variety of reasons it was not played in there, because the simulation didn't need it for us to get the kinds of insight that we were looking for. And so in terms of being able to get the number of systems out there for a dismounted infantry platoon to attack a motorized rifle company in the defense. So we have 40 soldiers attacking, and let's say 120 defending in a normal Lanchestrian type of combat situation, the attacker would be decimated. And really, inside in the simulation experiment, the platoon, as we played it base case with none of these robotic technologies, was defeated every single time. When we provided these technologies, when we provided the SMET with a SUAS launch and recovery capability, when we added an SMET with the loitering munition capability, that's when the platoon was able to defeat that company. Now, I will tell you that that platoon of 40 soldiers was doing a mission that in normal circumstances would have taken a 650 soldier battalion. So we were showing those 10x increases in effectiveness with a tooler system that we had not really thought our way through, and really it got to the point where Jeff's Arsenal C-17 that he's working with the Air Force on is what spurred us to say, if we could do an Arsenal modular mission payload on an SMET, that could give us now that ability to push those armed small UAS forward, to push those loitering munitions forward, and be able to have a capability that we had just, as I say, wished away back in 2019. So an interesting point in that experiment, and again, I think for those of you who have any kind of a background in operations research will appreciate this. Garth McDermott and his team members did a regression analysis on what was it, what specific systems allowed that platoon to be 10 times more effective. And I've mentioned that the third lethality system that we had out there was a lightweight 30-millimeter cannon on an SMET. And what the regression showed was the most important lethality system out there was the small UAS. The second most important was the loitering munition. And the 30-millimeter cannon on an SMET did not increase the effectiveness of the organization. So again, that now pushes us into this idea of being able to dominate the atmospheric littoral. And that atmospheric littoral, or actually, I think the new term for it is the air-ground littoral. That area between ground level and some coordinating altitude above a small unit, that if that small unit is able to be the dominant organization between friendly forces and the enemy, they will be successful. If you look right now at what's going on in Ukraine, they're fighting over that atmospheric littoral. They are the Russians and the Ukrainians are doing everything they can to be able to get their systems to have first the superiority and supremacy in that, and then be able to engage the enemy from that high ground, that key terrain that is out there right now. And again, I think that is what Tular, that is what the Arsenal modular mission payload on an SMET allows small units to do in the future. Over.
Yeah, great, Ted. Just for the listeners, BAE Systems approached us in the fall of last year and actually asked us to take our modular mission payload and put it on board one of their unmanned ground vehicles with their partner HTT Global. So if you go onto our YouTube site or even our website, you'll see that we actually mounted our modular mission payload on that UGV so that we had autonomy as a vehicle, autonomy as a launch and recovery capability. And the next step is to make it an Arsenal one by having it with multiple UAVs. So the need has already been articulated, as Ted's talking about, from a strategy perspective, and industry is already thinking about and responding to it. And it literally took us about 5 minutes to load the modular mission payload onto the unmanned ground vehicle. You can move it between those. You can move it on any vehicle for that matter as we go forward in time. So there's an ability to do what Ted's talked about doing, emerging with Target Arm here. So I got another question for you, Ted, that's coming up, and that is, how would you protect the forward line of sensors from enemy action? It seems like they would be out in the open without protection.
So absolutely, and the idea there is they are small enough, light enough, cheap enough where they are expendable, and I think that's kind of the issue that we have right now. Is many of our robotic systems come with very high costs. They come with economic useful lives that are measured in the sometimes in the decades, and the future, I think, is going to be robotic systems that are smaller, lighter, cheaper, expendable in use, and then for industry. The value proposition is that you're not selling one system, you're selling the first of many systems going forward. So as an example, for TULAR, especially an Arsenal MMP, you are pushing UAVs forward. UAVs are launched and recovered, and those UAVs are recovered into the Arsenal MMP. They are recharged, they are rearmed, they are repaired, and then as they go out to their mission, they push forward, and they are either successful, or they are destroyed, or something happens and they don't come back. They are replaced as part of that logistics pipeline of systems that are coming into the organization, and it is no longer a convoy that brings that material forward. Now that material from some point outside of the enemy's ability to engage it, it comes forward, and so you fly UAS forward. Ideally, you fly smaller, lighter, cheaper ground robots forward on larger. There's a program called Joint Tactical Autonomous Aerial Resupply System. So that would be a way for you to move robotic systems forward without having to put humans at risk, and without having to even have humans controlling all of that. That should all be done autonomously, so that you can have the humans do what humans do best, and that's not the dull, dirty, dangerous stuff. That's the things that require a human's I don't want to say intuition, but those human traits that allow you to make better decisions than robots with incomplete information. Over.
Great, thanks, Ted. We're ending up here. We got an opportunity for just another quick question if anyone has one in the last couple of minutes. So if you have one, please bring it forward. And there we go, we got one. Going off of that question, is the military requiring redundancy of sensors and sensor packages and or backups on AGV and other robots? That might be UGV, but autonomous ground vehicles.
So You know, I actually answered that question probably 8 or 9 years ago at a conference in London, and I was kind of booed off the stage. But the problem that we have right now is that we are always looking for exquisite systems, exquisite sensors, exquisite weapons, exquisite effectors. And I think the future, and again, look at what's going on right now in Ukraine. The future is good enough sensors, good enough effectors, good enough systems, robotic systems that go out there and do the work that needs to be done. Just because you can put a sensor on that sees 10 kilometers does not mean that you need to put it on a robot that probably only has a useful life measured in perhaps minutes or at best hours. If you look at what's going on right now in Ukraine, the Ukrainian army is going through 10,000 drones a month. Zelensky has said he wants 1 million drones out there over the next year. You don't field 1 million drones with exquisite sensors. You field them with good enough sensors. You don't need to put shock and awe quality weapons on them. You just need good enough weapons to have the effects that you want against the targets that you have out there. When I was a young cadet at West Point, I was told by one of the marksmanship instructors that it takes 57 foot-pounds of energy to kill someone, which is about 75 watts. I'm sorry, 75 joules. So 75 joules isn't very much. We need to reconsider the idea of overwhelming everything, because now we can have robots put the appropriate amount of energy and momentum at the appropriate time at the appropriate place, and we can do it at a significantly lower cost. Over.
Great. Thanks, Ted. That'll be the last question. We talked about getting done today at 12:45. If you'd like to get through and ask additional questions of both Ryan and myself, the information's there on the screen for you. We'd like to thank Ted very much for being a guest speaker today, and we'll continue this webinar series to start showing what's going on in the robotics and autonomy arena, because it's moving very, very fast, and it's coming into society at a clip that is going to catch most people off guard. So thank you very much for the day, and that concludes today's webinar. Thank you.